Hello everyone. In today's class we'll discuss the sequence reactions. Firstly we have CH3MgCl, which is methyl magnesium chloride reacting with carbon dioxide in the presence of acid. So here you can do like this. The CH3 group, if I take carbon dioxide like this methyl group will attack this carbon, one of the bond will break, so we'll get CH3 C double bond O minus, and this MgCl is bonded to this oxygen. Now you can break this bond and to this you can add H plus. So what do we get? Firstly we will get CH3COOH. So A is CH3COOH. Now that on reacting with lithium aluminum hydride, this is the best reducing agent. So if I take lithium aluminum hydride, see this CH3COOH, we know this is best reducing agent, so here reduction happens. So break this bond, add hydrogen, and break this bond, add hydrogen. So whenever you break this bond, this H2O molecule will get separated. And here we are breaking one of the bond between carbon and oxygen, and we are adding hydrogen atoms like this. So what do we get now? We'll get CH3, CH2, single bond OH, which is ethanol. So compound B is CH3, CH2, OH, which is ethanol. Now this alcohol reacting with SOCl2, which reaction is this? This is Darson's process. For this one simple trick is there. So whenever alcohol reacts with SOCl2, so that SOCl2 you can write like this. Now if you break like this, these are the products formed. We'll get RCl, HCl and SO2. These are the products formed. So R combines with Cl. This is our product. Here R group is CH3, CH2 that combines with Cl. So the product will be CH3, CH2, Cl. Right? Now, just 1 minute. Now, see this part. This is chloroethane reacting with alcoholic KOH. So, alkyl halide with alcoholic KOH means this follows Zaitsev rule, or you can say dehydrohalogenation. So what happens? You can remove chloro group from this carbon, hydrogen from the adjacent carbon, and you will get one extra bond. So you will get CH2 double bond CH2. See, normally if I write CH2H, CH2Cl. See this CH3CH2Cl I can write like this. So in dehydrohalogenation you can remove chlorine from one carbon and the hydrogen from the adjacent carbon atom, and you will get one extra pi bond. So what is the product formed here? It is CH2 double bond CH2, which is ethene. Then this ethene on reacting with Br2 in the presence of CCl4. This is dihalogenation. In this case, we will get vicinal dihalides. So our E will be, see, dihalogenation means you just break this pi bond, add one Br to this carbon, the second Br to this carbon. We'll get CH2Br, CH2Br. So the product, it is like this. It is 1,2 dibromoethane. So this is our E. This E on reacting with alcoholic KOH, again it follows Zaitsev rule or dehydrohalogenation. See, this NaNH2 also you can use it as dehydrohalogenating agent, which means for this reactant we have to do 2 times dehydrohalogenation. If you do 1 time, you can remove this Br. So if you remove Br from this carbon, you can remove hydrogen from the adjacent carbon. You just remove this. On second time dehydrohalogenation, you remove Br from this carbon, hydrogen from this carbon. So now we are having only CH. And whenever you remove 1 mole of HBr, you will get 1 pi bond. Second mole of HBr means another pi bond. So together we'll get CH triple bond CH, which is ethine. So here F is CH triple bond CH. Now this ethine on reacting with RHT, red hot tube, so it follows polymerization, right? So we'll get benzene ring, we'll get benzene. Now this benzene on reacting with Br2 in the presence of Fe dark condition means here halogenation takes place, especially bromination, will get bromobenzene here. So compound H is bromobenzene. Now this bromobenzene on reacting with concentrated HNO3 and concentrated H2SO4, these are what? Nitrating agents, right? Electrophilic substitution reaction, nitration, and here electrophile is NO2 plus. And this electrophilic substitution takes place at ortho and para position, and the major product will substitute at para position. So our final product, that is the major product, it is bromobenzene as it is, but we'll get NO2 group at para position. Now this 4-nitrobromobenzene on reacting with NaOH in acidic medium, this follows Dow's process. In Dow's process, what happens? Br group is replaced by OH group. So the same compound, instead of Br, will get OH in the case of J. So I'll just take this compound. In the place of Br, we'll get OH. Now this on reacting with CH3Cl. What happens here? This on reacting with CH3Cl, see, you can break this bond, correct? No, you can add CH3 group here, Cl group here. So we'll get OCH3 and HCl separate. So the product, it is benzene ring, NO2 group, and on top OCH3. Now this on reacting with excess of HCl, what happens? You can break this bond, add H here, Cl here, we'll get this product back. So we'll get benzene ring, OH, NO2, this is one product, and CH3Cl, this is one product. Now this on reacting with sodium in the presence of dry ether, what do we get? This is Wurtz reaction, no? We'll get CH3 single bond CH3. Now from which reactant? The reactant on reduction will get this. The reactant on adding H2 will get this product. It is ethene, CH2 double bond CH2. CH2 double bond CH2 on reacting with O3CCl4Zn means this is ozonolysis reaction. Here what is the trick? Wherever double bond is there, you just break that, add oxygen atoms like this. Now what are the products formed? We'll get HCHO. Again you see HCHO. So the product is HCHO. This HCHO on reacting with SBH, this is sodium borohydride, that HCHO I will take like this, and the sodium borohydride is what? Better reducing agent. So what happens? You just break this CO bond, one of the bond you break, and add hydrogen atoms like this. So what do we get? We'll get CH3 single bond OH. The product is CH3 single bond OH. Now we have this L, but L we are getting what? We are getting benzene ring, OH and NO2. Now this on reacting with NaI in the presence of dry acetone. No, this is not possible. You can take this NaI acetone for this. If you take that, you will get CH3I, which is Finkelstein reaction, halogen exchange reaction. Now this one, this para-nitrophenol on reacting with sodium bicarbonate, what are the products formed? We'll get, the P will be at para position nitro group as it is, but instead of OH we'll get ONA, and the gas released in this case, it is CO2 gas, right? Which means these are the products formed. Only this one you change. From M only you take NaI in the presence of acetone, what product will get? Will get CH3I, halogen exchange reaction, which is called as Finkelstein reaction, right? Thank you.